Good afternoon. So already we completed 8051 assembly level programming. So apart from assembly language, we need to do programming in embedded C. We'll just go through the concepts of embedded C, and we'll have a demonstration on embedded C programming and peripheral interfacing. So basically, what is embedded C? Embedded C, whenever the conventional C language and its extensions are used for programming embedded systems, it is referred to as embedded C programming. So what are the advantages of embedded C programming? It is a mid-level with high-level features and low-level features. C, when used correctly, is safe and robust as any other high-level language. It directly manipulates the hardware and memory addresses. Now the comparison between C and embedded C. C is a well-structured and well-defined and standardized general-purpose programming language. In case of embedded C can be considered as a subset of conventional C language. C, a platform-specific application known as compiler, and it is used for the conversion of programs written in C to target processor-specific binary files. In case of embedded C, a software program called cross compiler is used for the conversion of programs written in embedded C to target processor controller specific instruction. Now, compiler versus cross compiler. Compiler is a software tool that converts a source code written in high-level language on the top of a particular operating system running on a specific target processor architecture. Cross-compiler are software tools used in cross-platform development application. In cross-platform development, the cross-compiler application, the compiler running on a particular target processor OS that converts source code to a machine code for a target processor whose architecture and instruction set is different from the current development operating system environment operating system. Okay, so now we'll go through an embedded C example. So initially we'll do a program in 8051 embedded C for LED blinking. So as usual, we will do the programming in Keel software. So we need to create a project, then select the hardware. So we are using 8089C51. So now created a project. So now in this platform, we are going to do the programming. So this is the program, or included a header file. Then we done the programming. When we are saving this program, you have to save with .c file extension. In assembly language programming, that time we used .asm format. Here we need to use .c format. Now we need to add the program. The code name was blink 1.c. The program is added. So here what we are doing is we are using, instead of assembly language, here we are using embedded C. So all the registers are available in this reg51.h header file. So we included this header file for 8051 microcontroller. And here we are going to blink one LED which is connected to port P2.0. So this is the syntax for defining the port. We map the port P2.0 to a variable LED. So in embedded C, you can use sbit instruction for mapping. Then we initialize a declared a function for delay. So this is the function declaration for delay, and this is the delay function. So here we are using two integer data type j and I, and created a for loop. And this is the infinite loop for LED blinking. This is the main function. Here P2.0 is 0, and we'll call the delay function. Then what? We'll call the delay function. This is a simple LED blinking program. So I will just show you the blink program in assembly language. Then we'll compare the assembly language program with embedded C. L1, just a loop L1, P2.1, P2.0, for delay, STMP L1, delay function, using to register move R1, 0H. Okay, user FFH. And PJ and SF R, P3, R, L2. So this was the assembly language program for the same operation. Here we are complementing the values in port P2.0. For that, this is the function for delay, and this is the main function. So compared to this program, here we are just creating a for loop. So we don't need to bother about the exact hardware architecture of the microcontroller. So without having much understanding of the internal architecture and the functions of special function registers and all, we can easily create an LED blink program in embedded C. Now we'll build this program. Okay, so no error and no warning. So we can create the target file. To creating hex file, we need to define the location for the hex file. So I'm creating the hex file in desktop. Hex file name is blink1. Create hex file. So now we created a binary file for LED blinking. Now we can upload this program to the hardware. So here we are using AT89051 microcontroller, and P2.0 is our port. So we connected one LED, and the value at P2.0 we will blink with a delay. So select the hex file, blink1.hex, then execute it. So we can see here with some particular delay the LED is blinking. So this is one simple example for creating lab manual. Apart from this blinking in embedded C, you also need to do a ring counter, Johnson counter, then interfacing liquid crystal display with HRFIR microcontroller using embedded C programming.